If you stop at any active construction site and look at the machinery lined up along the perimeter, a pattern appears almost immediately. The excavators are yellow, the bulldozers are yellow, the wheel loaders, the compactors, yellow, yellow, yellow. And yet, cars in the parking lot next door come in dozens of colors. Nobody decided all cars should match. In industrial design, almost nothing is random. So why do the largest, most dangerous machines in everyday civil construction converge on a single color? The answer reaches into human biology, engineering history, and decades of hard-won safety walk onto any active construction site. And the first thing that registers is the visual complexity. Machines moving in multiple directions, workers on foot crossing between them, grades changing, temporary roads appearing, stockpiles shifting position by the hour. This is not a controlled factory floor with painted lanes and fixed barriers. It is a dynamic environment where conditions change constantly and where the margin between a close call and a serious accident is often measured in reaction time. In that environment, the single most reliable safety variable available is whether a machine or a worker can be seen, and seen quickly enough to matter. That is the foundational challenge behind construction vehicle color. It is not an aesthetic question. It is a visibility question. And visibility here is a functional engineering variable with direct consequences. A machine operator sitting several meters above the ground, looking through a narrow cab window, often with dust or glare reducing clarity, depends on contrast to detect movement at distance. A worker on foot, focused on a task, relies on peripheral vision to register an approaching vehicle in time to react. The critical metric is not whether something can eventually be seen. It is how quickly it can be detected, under variable lighting, against a background that is never fixed. That is why color matters as an engineering input. Different colors perform very differently, depending on what they are seen against. A red machine against brown earth can blend into the background under certain lighting. A white machine in direct sun creates glare that reduces detection rather than improving it. A gray machine against overcast sky and concrete can become nearly invisible at distance. The question engineers and safety researchers began asking in the mid-20th century was precise. Which color provides the highest contrast against the widest range of backgrounds found on real construction sites across the broadest range of lighting conditions? The answer starts with the human eye. Human vision is not equally sensitive across the visible spectrum. Under standard daylight conditions, the eye's peak sensitivity sits in the yellow-green range, near wavelengths of approximately 555 nanometers. This is not a marginal difference. Sensitivity at this peak is substantially higher than sensitivity to red and far higher than sensitivity to blue or violet. That biological fact is the foundation of why high-visibility colors in safety applications almost universally fall in the yellow-green band. The eye detects them faster, at greater distances. In the end, the eye does not treat all colors equally, and construction safety cannot afford to ignore that. Yellow specifically performs well across an unusually wide range of real-world backgrounds. Against brown and ochre soil, yellow provides strong contrast because the hue reads as distinct even when luminosity is similar. Against green vegetation, yellow separates clearly because the eye distinguishes warm tone from cooler, darker green. Against gray concrete and asphalt, yellow stands out sharply. Against a blue sky, the contrast is immediate. No single color performs optimally against every background, but yellow comes closer than any practical alternative across the specific combination of environments where construction work actually happens. That is why visibility research and field experience kept returning to the same answer. The comparison with other colors makes the reasoning concrete. Red is already saturated throughout construction environments in warning signage, brake lights, and hazard markers. A red machine does not stand out against that visual noise. It disappears into it. White reflects well in some conditions, but produces significant glare problems in direct sun and loses legibility at dusk or in low-contrast overcast light. Orange performs adequately in certain contexts, but loses contrast against clay-heavy soils and autumn vegetation. Blue and gray offer almost no contrast advantage against the natural backgrounds of a construction site. Yellow, by elimination and by measurement, remained the strongest practical option across the full range of conditions that matter. That practical conclusion found a formal anchor in one company's decision. In 1931, Caterpillar began painting its equipment a specific shade it would eventually trademark as highway yellow. The choice was deliberate. Caterpillar's engineers understood that equipment operating alongside road traffic and in open construction environments needed maximum visibility, and field experience kept pointing toward yellow. As Caterpillar grew into the dominant global manufacturer of heavy construction equipment through the mid-20th century, its color choice carried enormous weight. When the most widely distributed machines in the world were yellow, yellow became what contractors expected, what operators were trained around, and what safety programs were built to reinforce. In the end, one manufacturer's early decision became an industry's default standard. The feedback loop that followed was powerful and self-reinforcing. Training programs taught workers to treat yellow as the standard visual signal for heavy-moving equipment. Fleet managers standardized on yellow because mixed-color fleets created unnecessary visual confusion on busy sites. Parts suppliers, maintenance crews, and rental companies all oriented around the yellow baseline. That is why new manufacturers entering the market faced a straightforward choice: differentiate with another color and accept unfamiliarity, or adopt yellow and fit seamlessly into existing workflows. The market had already decided what heavy construction equipment was supposed to look like. But yellow is not universal, and the exceptions reveal exactly why it became the standard. Military construction equipment is the clearest counterexample. An Army bulldozer or combat engineering vehicle is typically painted olive, drab, or camouflage, and the logic is the precise inverse of civilian safety reasoning. On a military operation, visibility is a liability. The same property that makes yellow ideal for a highway construction site, maximum contrast against natural backgrounds, makes it dangerous in a combat context. The color choice is not random in either case. It is a direct response to the specific environment and the specific risk being managed. Airport ground equipment presents a different exception. Tugs, baggage carts, and fuel vehicles at major airports are often painted red or bright blue. The reason is the environment. Airport tarmac is a controlled gray surface with painted markings and edge lighting providing visual structure. That is why airport operators select colors calibrated to their specific visual environment rather than defaulting to the construction standard. Mining operations introduce further variation. In large open-pit environments, high-visibility lime green and orange appear alongside yellow, and some operations use white for certain vehicle classes. In very dusty conditions, white can be easier to spot through haze. In sites where ore coloration tends toward yellow and ochre, lime green provides stronger contrast. The principle remains consistent across all three exceptions. Color is selected to maximize contrast in the specific environment where the machine operates, against the specific backgrounds and lighting conditions of that site. Visibility, aerodynamics, structural design, and operating economics. The variables change, but the engineering logic does not. Utility vehicles add one final dimension. Water trucks, gas infrastructure vehicles, and electrical maintenance equipment frequently appear in white, blue, or company-branded colors. Here, regulatory, identity, and heat management enter alongside visibility. A gas company vehicle must be recognizable to the public and to emergency responders. White reflects heat effectively for vehicles carrying temperature-sensitive equipment. These are not safety failures. They are cases where multiple engineering variables are balanced simultaneously, and visibility is one input among several. In the end, the exception proves the rule. When visibility is the dominant variable, yellow wins. The historical consolidation of yellow accelerated through the post-war construction boom of the 1950s and 1960s. American infrastructure expansion, highways, dams, airports, suburban development drove enormous demand for heavy equipment, and American manufacturers set the visual standard that spread internationally. By the time formal safety standards began to codify color requirements, they were confirming what industry practice had already established. ANSI standards addressed high visibility color, SOLDA requirements for worksite equipment and marking. ISO frameworks extended those requirements internationally. These regulatory bodies did not invent the preference for yellow. They formalized it, giving it institutional permanence across markets that American manufacturers had not yet fully reached. Today, the convergence is nearly complete. Caterpillar, Komatsu, JCB, and hundreds of smaller manufacturers all work within the same narrow band of the spectrum. Subtle variations in saturation and warmth serve as brand identifiers, but the underlying color remains constant. That row of yellow machines on the roadside is not coincidence, tradition, or aesthetic preference. It is the visible result of engineering decisions made at every level, from the sensitivity curve of the human eye to the trademark filing of a single manufacturer to the formal frameworks of international standards bodies. In industrial design, almost nothing is random, and the color of a bulldozer is no exception.